We pride ourselves here on the Everything Electric Show that we get to bring you the latest and greatest in the world of clean energy and electrification. And today is no exception, because today we're bringing you a world first. The world's first high temperature heat pump installed in a brewery. This is Hepworth Brewery in Sussex. That's a badly poured pint. And this is the Everything Electric Show. Try Everything Electric at our exhibitions in Australia, Canada and the UK. Next up, London. When we think about industrial heat, our mind often turns to those big industrial heavyweights, things like cement, aluminium and steel manufacture, processes that require temperatures in excess of 1,000 degrees C. But there are a ton of industrial processes that actually use temperatures that are much more modest, between 100 and 200 degrees C. Things like beer brewing, but also stuff like chemical refining, making paper, making textiles, making food. And here's the kicker. Those processes are actually incredibly polluting, and their global emissions equate to more than the entire global aviation sector. So clearly there is a huge incentive to decarbonise, but to date there hasn't really been an adequate solution, and frankly it's often cheaper just to burn gas. Now if we take a domestic heat pump, they take low-grade heat, think ambient air, transform it into high-grade heat, think domestic hot water. But those systems typically top out at a temperature of around 80 degrees C. We have of course seen some really interesting alternatives, think caldera and heat batteries. But a heat pump that could affordably reach those higher temperatures, that's been out of reach. Until now. A fun fact for the car nerds out there, the barley used to make the beer here actually comes from the legendary Goodwood estate, home of course to the Goodwood Festival of Speed. Now once that barley has been milled and mashed and the liquid extracted, that is called the wort, and the wort then gets boiled in this, which is a kettle. Now this part of the process is exciting for two reasons. One, it's where the hops get added for those lovely beery aromas, and two, this is where the heat pump comes in. Now typically this would have been heated by burning oil, and the steam generated would have just been vented to the atmosphere. Now, instead of venting that steam to the atmosphere, it's captured, goes through this pipe here, and that's what feeds the heat pump. Now that then heats refrigerant, it goes to a compressor, it steps up that temperature to a sizzling 130 degrees C to create new, fresh steam, which then continues to power this process or to heat this process, and so it can continue in that closed loop. And the beauty of all of this is that it reduces energy consumption by 90%, produces 90% fewer emissions, and reduces running costs by 40%. And at the heart of all of this magic is a compressor technology called a TurboClaw. And to get into that, we need to speak to the experts. We're really excited to partner with Duracell Energy to showcase their amazing renewable energy solutions. If you want to reduce your energy bills and join the renewable energy transition, installing home battery storage and solar panels at home is a great way to start. Duracell Energy's ecosystem of products typically partners with solar panels, but they can be just as effective without it, particularly for electric vehicle owners or anyone looking to take control of their energy. And with Duracell Energy's Platinum Homeowner offer, viewers can get a custom service that pairs you with top quality products and the best installers in your area. Duracell Energy's batteries, inverters and EV chargers work together on one easy-to-use app. With features like dynamic tariff integration and grid services, you'll be able to maximise your return. Ready to get started? You can get your quote today. And don't forget, we're also giving away a Duracell Energy Bunny in every episode. Just answer the question about Fully Charged by following the link in the description. Good luck! We talk about heat pumps all the time on the Fully Charged Show and Everything Electric Show, and we know with heat pumps that once you take an input temperature, it's all about stepping it up to that higher temperature. And in a domestic setting, you've got a lower temperature and it goes to a higher temperature. But in this particular instance, your initial temperature is already higher. So what is it about the Futraheat solution that's actually special and makes it so well suited for those high temperature processes?
So the whole situation in industrial heat recovery is different. You're not taking heat from the air or from the ground or from water and using it to heat a space or hot water. Mm-hmm. You are recovering heat from an industrial process, a manufacturing process, typically something like cooking or drying or distilling. And you're recovering that and reusing it, recycling that heat. So that's why you start with a higher temperature. You typically start with temperatures somewhere just below 100 degrees, or 80 or 90 degrees, and take that back up in the form of steam to drive the process in the first place. As I say, closing that energy loop and recycling it. Now, Futraheat, we're one of a number of companies that are looking to do this. But what makes us different is that at the heart of our heat pump, we have a compressor called TurboClaw, and this is unique to us. What makes it unique? It's a turbo compressor, which in itself isn't unique, but it's a turbo compressor that works at the size that most of industry needs it to work. Turbo compressors are great. They've existed for 100 years. They're used in all sorts of applications, but they work best when they're compressing an awful lot of gas. And that isn't what we're doing when we're looking to address 1 megawatt and sub-megawatt industrial heat pump applications. The alternative to turbo compressors are positive displacement compressors, pistons, screws, scrolls. Now, these typically are used in these smaller applications in industry for refrigeration, for chillers, for lower temperature heat pumps, but they all require oil in their working system, in their refrigeration loop. And once you mix refrigerant with an oil, and then you add in the additional temperature, that's where you come across a lot of problems. And those problems manifest themselves in terms of maintenance issues, breakdown, performance issues over time, and actually fundamentally in the compressor itself, where you need a more complicated compressor with a lot more moving parts, touching parts, wear associated with that, and an ancillary system to manage this combination of oil and refrigerant.
The world of turbo machinery has existed for so many years. We really understand sort of steam turbines, for example, and yet we haven't seen them in this application before. Why is that?
It comes down to the fact that we're able to operate as a turbo compressor in this operating space, this sub-megawatt high-temperature heat space. So going back to the market demand here, probably a third of all applications for this kind of heat pump are in this lower sub-megawatt space. So that's where the pull is. And of course, until now, there hasn't been a turbo compressor solution to satisfy that part of the market. TurboClaw, if you were to look at it, looks very different. Its geometry is entirely different from a normal turbo compressor. So it's not as if there's been the opportunity for a gradual evolution from a conventional turbo compressor to TurboClaw. It's a complete step change, something totally different. So we've only been able to do it now.
Hepworth Brewery isn't just thinking about heat pumps, it's thinking about sustainability across the board. The brewery's roof dons an array of solar panels, while reed beds ensure wastewater is safely returned to the nearby River Arun. Ingredients? Locally sourced, of course, and when it comes to leftovers, Hepworth has that covered too. Water with high yeast content is repurposed as a soil conditioner, while spent hops and grain find new life as an animal feed. Broken glass is recycled, and so too is waste heat from the beer chillers, which is put to work keeping the offices and visitor centre lovely and warm.
We make really good beer.
That goes without saying. We're going to try some for ourselves.
No, it doesn't. That's why I said it. No, I mean, part of our ethos is to make beer as wholesomely as we possibly can as well. So it's not just the ecological side. So we don't use preservatives, we don't use additives, we don't pasteurize. We try and use the traditional methods developed over hundreds of years by guys who had less science and technology to their fingertips than I do. So all these initiatives actually must not affect our brewing quality. We all love beer. That's why we're in this industry. And we just don't feel that we should be destroying the planet to do it. And we believe it is possible to do it without producing a load of emissions.
And when Futraheat came to you, were you sceptical? Did you think, this could be a really good solution? What was some of your thinking there?
Well, we'd already made our own heat pumps here from our coolers.
Yes.
So we actually got beer source heat pumps. We know they work. It was a tremendous benefit. So when somebody came to us with a heat pump that would work right at the high level, we felt it was worth investigating.
Aside from saving carbon, what other benefits have you observed through implementing certainly the heat pump with Futraheat, but also some of the other innovations that you've implemented as well?
Well, a lot of this is actually about reducing waste. So it might be heat that we're wasting, in the case of a heat pump, or it can be other things. So if we're always working towards that, as a manufacturer, that's inbred into you. So we will always go that route. But it all has to be financially sound. So with all our initiatives, we try to say they've got to be real. They've got to be monetarily real. Although we're a small company, we can make those investment decisions ourselves. In a big corporation, there will be rules.
Yeah.
In our corporation, if we can get a return in what we might consider to be a reasonable length of time, we will still do that.
As impressive as all these steps are, there's one detail that you might have noticed. The initial work boiling, before the heat pump takes over, still requires an oil-fired boiler. While they've made significant strides in reducing energy consumption by only using the boiler to kickstart the process, the question remains: how can they eliminate it entirely and say goodbye to burning fossil fuels for good?
So you're right, at the moment we're not decarbonising the whole process, it's part of the process, it's the wort boiling. To decarbonise the whole of the wort heating and boiling process, we would need to recover the heat from a lower temperature source in the first place. Now that could be a lot of the abundant hot water they have here, for instance. What we will require from the heat pump there is something which can give a greater lift. The heat pump outside provides a 30-degree lift at the moment, but our next model later this year will provide a 60-degree lift. So we'll be able to take water temperature, for instance, down to from 70 degrees up to the 130 degrees.
So actually by finding those other sources of waste heat, you could start with a lower temperature, and also at the same time you're working on those bigger step changes of temperature as well.
Exactly, so you're covering more of the process. The other thing we can do is that the heat pump out here is actually oversized for the one brewing line that it's on. It could actually accommodate all 4 brewing lines if the brewing schedule is staggered appropriately. So that would actually decarbonise 4 times as much as we're doing with this initial pilot.
So beyond beer brewing, what other industrial processes could this be applied to?
Frankly, it could be applied to a whole raft of processes, but one of our sort of target industries is food and beverage, and of course brewing fits within that. Why? Well, typically in food you're drying something, or you're cooking something, you're sterilizing something, pasteurizing, distilling something. And these typically need temperatures between 100 and 150 degrees. And what you've generally got as your waste heat from these processes is hot water. In some cases, air and humid air, but mostly hot water. So those sorts of applications are the lowest hanging fruit, if you like. But looking further sort of afield from that, paper manufacturing, an incredibly energy intensive process. So there's lots of opportunity there. Chemicals, again, distillation is a big process within chemical manufacture, and I include pharmaceuticals in that as well. So these sorts of applications are the most appropriate, and also at a scale level. They tend to need this 1 megawatt of heat down to maybe 300 kilowatts of heat in a sort of decentralized way.
Here in the UK, domestic households can be eligible for the boiler upgrade scheme to switch from an old gas boiler to a brand new shiny heat pump. Is there anything equivalent for industrial businesses?
No, sadly not. This is something that industry and businesses really need to reduce the capital outlay for such technologies. There's no doubt that heat pump technology, in terms of its capital outlay, is more expensive than a traditional boiler. You will save over time and save significantly, but that capital outlay can be a real barrier in the first instance. So we do need those kinds of incentives from government and through policy. There's some help when it comes to carbon, cost of carbon within businesses, and that does end up on the on the balance sheet. So that's of some help, but government really needs to go a lot further.
This isn't just about cutting carbon. This is rethinking processes to make them more cost effective and efficient. It's about combining different technologies and taking old ideas and using them in new ways. And I personally think that is perfect food for thought while sipping on a Hepworth beer. Please do like and subscribe, and if you have been, thank you for watching. Cheers.